1, 2, 3, 4, 5. HVZ reaction. It directs electrophile to meta position. Greater than H2CO3 can give reaction with a nucleophilic attack it is. There is benzylic hydrogen. Then they can form COOH. Solve these 9 most commonly repeated question patterns from carboxylic acids and their derivatives. Hello students, let us start. 9 must-do PYQs from this chapter. JEE Mains 2024 question. See, product C in the following sequence of reactions has dash pi bonds. So we know whenever KMnO4 KOH, that is on heating, here it gives, so respect to salt, that is COO K plus and CO minus. Upon hydrolysis, it gives COOH. Upon bromination, it directs electrophile to meta position. They mention mild condition. So these are most repeatedly asked questions from carboxylic acid chapter. So number of pi bonds, COOH having 1 pi bond, inside 3 pi bonds. Structure is like this. Or you can specify clearly here, benzene ring 3 pi bonds and COOH 1 pi bond. Here there is 1 pi bond, benzene ring having 3 pi bonds. Total answer is 4. Next, identify the product P in the following reaction. So here what you will get? Br2 red phosphorus H2O, Br2 red phosphorus H2O. So first of all, HVZ reaction. HVZ reaction, what happens here? Alpha halogenation occurs. So alpha halogenation occurs. So here directly you will get option B here. Okay. See next question here. Here in this case, you can observe it. JEE Mains 2024 question. Identify major product P formed in the following reaction. Anhydrous AlCl3. So which reaction occurs here? Friedel-Crafts acylation reaction. Friedel-Crafts acylation, what happens here reaction? So here electrophile is formed. So it will attack at any carbon atom. So here after this 4 should be correct answer in this case. JEE Mains 2025 question. Which of the following compounds is least likely to give efflorescence of CO2 in presence of aqueous NaHCO3? Just now we discussed compounds with acidic strength. Compounds with Ka, acidic strength that is greater than H2CO3 can give reaction with NaHCO3. Generally, phenols will not give reaction with NaHCO3, but it is picric acid, 3 nitro groups. So due to which it can give efflorescence CO2 reaction, that is evaluation of CO2 readily. Carboxylic acids will give reaction with it. Even it can give reaction like aniline plus HCl, aniline salt it can give reaction which is having more acidic strength than H2CO3. But here phenols which cannot give, only one NO2 group present which cannot give reaction with NaHCO3. Remember, general phenols will not give reaction with NaHCO3. Next question. JEE Mains 2025, consider the following molecules. So a rate of hydrolysis. So rate of hydrolysis, like you can consider like nucleophilic substitution reaction. Everywhere you place positive charge on here particular carbon. Here also you see. Here also observe it. Whichever group stabilizing positive charge, that shows maximum rate of hydrolysis. Whichever group is, like you can say, wherever there is more positive charge, which can show readily nucleophilic substitution reaction. So here we know it is minus I group, here it is plus M group, even it is plus M group, right? So we need more positive charge on carbonyl carbon. So you can specify like this: more positive charge on carbonyl carbon, that is directly proportional to rate of reaction. Nucleophilic attack it is. Nucleophile attack here, like OH minus attack here it is. So more positive charge required. So like here chlorine can produce more positive charge. But next it is plus M group present, but immediately there is minus M group. So here it is balanced. CO group also present here minus M. So after first compound, second compound Q can show somewhat positive charge. But here no such minus M groups, only it is plus M group. Again NH2 is more stronger plus M group. So plus M group we don't need actually. Here what we need? Here we need minus M plus M. Directly proportional to minus M, inversely proportional to plus M. Okay. Or you can specify minus I by plus I. So wherever more positive charge on carbon, that shows more nucleophilic attack. Fourth option. Next, total number of compounds from below when treated with hot KMnO4 giving benzoic acid. Here we know if there is benzylic carbon, if there is benzylic hydrogen, then they can form COOH reaction with KMnO4. Benzylic hydrogen, yes, here it is present, it can give. Here also benzylic hydrogen, which is benzylic group. This position is benzylic group. It is benzylic group. So here, but there is benzylic carbon, but there is no hydrogen here. No hydrogen required, at least one hydrogen. Here, yes, it is possible. Here, no hydrogen. Here, it is possible, but we need benzoic acid. But two benzene rings available here. We don't need it. It cannot produce benzoic acid. So, how many compounds? See now. How many compounds will give? 1, 2, 3, 4, 5. 5 compounds. Answer is here 3. Next. JEE Mains 2025 question here. See, the compounds that produce CO2 with aqueous NaHCO3 solution are, again same, carboxylic acid can produce, phenols will not produce, picric acid can produce, carboxylic acid can produce, again phenols will not produce. So here, which can produce CO2 with NaHCO3 solution? So now here ACD, only ACD, that is correct option. Next. JEE Mains 2024 question. Here you can see 2024 question. Major product B of the following reaction has dash pi bonds. So whenever we do this, first you will get COOK, or you can write a COOH finally after hydrolysis overall. When it is allowed to react with nitration mixture, as COOH is -M group which directs electrophile to which position? That is meta position. Overall, how many pi bonds? Here pi bonds you can see in benzene ring 3 pi bonds, nitro group 1 pi bond, COOH 1 more pi bond. Overall, if you see 5 pi bonds is the answer. Next question. Consider the following reaction. From these reactions, which will give carboxylic acid as major product. They mention mild condition. If it is mild condition, we know hydrolysis of cyanide will give amide, mild condition. If it is normal, if nothing is given, we write carboxylic acid. Even here we will get RCOOH, Grignard reagent reaction with CO2. Here it is Stephen's reduction. Stephen's reduction will give RCHO. PCC will convert CH2OH into RCHO. Here first, with respect to this, here you will get which one? That is CHO, you will get benzaldehyde. But further bromine water, further mild oxidizing agent converts it into COOH. So how many giving COOH? 1, 2, any other giving here? So nothing, right? So B and E only B and E give carboxylic acid as major product. So these are most repeatedly asked questions from carboxylic acid chapter. If you did not watch previous chapter videos, PYQ videos, once again go through. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you everyone.